Welcome class 9 students. Student of class 9, today I will discuss the theorem that is known as midpoint theorem. Uh, Today I will prove this theorem, and the statement of the theorem is given that line segments joining the midpoints of two sides of a triangle is parallel to third sides and it is half of it. So what is given, students? Given that a triangle is given, and the triangle I am taking, the triangle ABC, the line segment joining the midpoint of two sides of the triangle. So I am taking the midpoint of AB D and midpoint of AC E. That line segment will be parallel to BC, and that is also half of AC. So in it is given in triangle ABC, D and E are the midpoint of sides AB and AC respectively. Okay, that is given. What do we prove? We have to prove what do we prove? That DE parallel to BC and DE equal to half of BC. So we have to prove that DE parallel to BC and D equal to half of BC, and to prove this theorem, we need to draw some construction. That construction statement is produce DE such that CF will be parallel to DB or AB. That is produce up to F. Okay, produce D up to F such that CF will be parallel to D. That CF and DB will be parallel to each other. So again I am telling you from the beginning that line segment DE of the midpoint AB and AC, that is D and E, will be parallel to BC and half of BC, and produce DE to F such that CF will be parallel to AB. These are the condition. This is given, and we have to prove DE parallel to BC and DE and D equal to half of BC. This is the theorem, and we have also written the construction statement that produce D up to F such that CF will be parallel to DB. Now by taking the help of those things, we have to prove the theorem. So I am taking here proof in triangle ADE and triangle ECF. We will prove these two triangles are congruent. First of all, students, this one angle and this angle 1 and angle 2. I am giving that angle 1 equal to angle 1, angle 1 equal to angle 2. Why? Because they are vertically opposite angle. Okay, they are vertically opposite angle. Next, this angle and this angle A equal to angle C. What is the reason between this? That this angle equal to angle C, because that DE parallel to CF means AB parallel to CF and AC their intersector. It's either intersector or transversal. So angle C equal to angle A because AB parallel to CF and AC transversal. Okay, AC transversal means these are the alternate angle. Okay, these are the alternate angle. So and A equal to EC. AE equal to AC. Why these two are equal? Because AE equal to AC. These two are equal because E is the midpoint of AC. is the midpoint of AC. So we have equal three conditions, that angle 1 equal to angle 2. These are the angle 1 equal to angle 2. These are the vertically opposite angle. Angle A equal to angle C. That is Z form. It means alternate angle because AB parallel to CF and AC is the transversal. And angle E and side AE equal to side EC because E is the midpoint. E is the midpoint here given in the E is the midpoint of the side AB. So you by the help of ASA, we can prove that triangle ADE congruent to triangle CEF or AEF. Student, I am rubbing that portion, upper portion, that statement only, okay, and also given. Now, students, as AD equal to CF, what can we say? That you can say that AD equal to CF, that is by CPCT. Okay. Now, students, as DB and for AD equal to CF and also AD equal to CF, okay. So and as DB parallel to CF and DB equal to CF. Why DB equal to CF? Because AD equal to CF, D is the midpoint. It means AD equal to DB. Here AD equal to also DB. AD equal to CF and AD equal to DB. It means left hand sides are equal. It means right hand sides also be equal. CF equal to DB. That's why I have written that's DB equal to CF. So in quadrilateral DBCF, DB parallel to CF and DB equal to CF. It means quadrilateral DBCF is a parallelogram. Because we know that if one pair sides are equal as well as parallel, then the quadrilateral is called parallelogram. Now, as it is parallelogram, as DBCF is a parallelogram, you can say that DF parallel to BC, because we know that opposite sides of the quadrilateral parallelogram are parallel. DBCF is a parallelogram. We have proved it earlier. So DBC parallel to DF. In short, DE. DF means D is also parallel to DE is also parallel to BC. So we have proved the first portion, that is DE parallel to BC. Another part, that is we know that DF equal to BC. Why? Opposite sides of parallelogram are equal and parallel, and DF equal to DE plus EF equal to BC. Okay, DF equal to. Now, students, one thing, AD parallel to CF, AD equal to CF, and also DE equal to EF. We can write here DE equal to EF by CPCT also. CPCT means opposite sides of this angle, DE, opposite sides of this angle, that is it. So DE equal to EF. In place of EF, you can write DE plus DE equal to BC. Why EF equal to DE? Because by the CPCT rule, opposite sides of angle A, DE, opposite, and angle A is equal to angle C, then opposite sides of angle C, that is EF. That's why these two portions are equal. So in place of D, you can write, in place of EF, you can write DE. So 2DE equal to BC. So DE equal to half of BC. So This is the second proof. Okay, this is the second proof. So again I am explaining from the proof that triangle ADE and triangle EFC, this angle equal to this angle because alternate angle, this angle equal to this angle, the vertically opposite angle, and AD equal to and AE equal to EC because it is given that E is the midpoint of AC. So these two triangles are congruent. As these two triangles are congruent, you can say by CPCT rule, that is, and DE equal to EF, we have set AD equal to CF by CPCT rule, and AD equal to DB because D is the midpoint. Okay, that is not by CPCT rule, but that is given in the theorem. So by the help of, as DB parallel to FC, because that is by construction, DB parallel to FC. So DBCF is a parallelogram. As it is a parallelogram, so we know that opposite sides of a parallelogram are also equal. So you can say BC parallel to DF, BC parallel to DF. Yes, DF parallel to BC. As D is the part of DF, so then DE also parallel to BC. This is the first proof. Now DBCF is a parallelogram, so opposite sides of a parallelogram are equal. Therefore BC equal to DF, and DF means DE plus EF, Okay, so in place of EF you can put DE because we have proved here DE by CPCT rule, DE equal to EF. So DE plus D equal to F, and D equal to half of BC. So students, in this video we have proved the theorem. We have discussed the theorem, midpoint theorem. Next video we will discuss on the converse statement of the midpoint theorem, and also we will prove that theorem. Thank you, students.